Welcome. In this video, I'll explain you the working principle of RFID communication. RFID reader and tag communication between both. So before going to the working principle, let we see the frequency bands for the RFID communication. We have the major three types: low frequency, high frequency, and ultra high frequency. Here is the frequency range and the distance, reading distance for the three different range. For low frequency, the frequency range is 125 to 134 and the reading distance is up to 10 centimeter. For high frequency, the frequency is 13.56 megahertz and range is up to 1 meter. And for ultra high frequency, the frequency is 860 to 960 and the reading distance is 10 to 15 meter. So if we go for the block diagram for the tag inside contain the power supply, circuitry, and TA transmission modulator and receiving demodulator, and it also contains the control logic and the memory cells. So how this tag can communicate between the reader, RFID reader and tag, how they transfer the data. So first we need to know that there are two types of RFID tag: active and passive. Active contains the battery and the passive do not have the battery inside. The most commonly used are the passive tags. So let we discuss how the RFID reader and the passive tag they do the communication. So let's go for the working principle and the communication. Here we can see the basic technique that used for the communication. We call it electromagnetic induction. This is for the near field communication. Here is the RFID reader. RFID reader transmit the data. If we see the more detail like this, here you can see energy plus data both together are transmitted. How the energy is transferred from reader to tag. Here you can see the reader transmit the high frequency signals. Here you can see the frequency. So this inductor produce the electromagnetic waves. These electromagnetic waves, changing electromagnetic waves, produce the current in the tag side inductor. So this, if we see the more detail like here, you can see here we show some circuitry. So these changing electromagnetic waves produce the current in this inductor, that is on the tag side. So this current, we filter this current using the diode and capacitors. Here we save some energy in the capacitor to operate the controller of the tag. So that was the process to transfer the energy from RFID reader to tag. So how we read the data from the tag, that is the thing now. Here the tag is not transmitting back the data. We use the technique that is called the load modulation. What is the load modulation? You can see this inductor work as a load for the RFID reader. So the change in the load current can cause the change on the reader current. So how we change the load? For example, if we transmit this data is 10110100. So in case of 1, we just short circuit this load, and in case of 0, we just open this load. Here is, you can see NPN transistor. So we can short circuit and open this load. So these change of load can be transferred to the RFID reader. So because here if the load is changed, we can detect this change of load on the reader side in this form. So here we also have some filter circuit. We can detect this change and we can demodulate this signal to read what the tag send the data to the reader. So we can read the same data and demodulate, and the received data we can get after demodulation as we transmit from the tag side. So that was the technique how we can read the data from tag to the reader. So this technique is called the load modulation. In fact, tag is not sending back the data. That the tag is just only changing the load according to its data what the tag want to send back to the reader. So that was the short communication. For the long communication, what we do, this technique is called the electromagnetic coupling. RFID reader transmit the data first and then tag send back the weak signal to the reader. So in that case, we need to focus on the impedance matching between the RFID reader and the RFID tag. So if the impedance is matched, this back signal would be stronger. If the impedance is mismatched, this signal would be weak. So in case of weak signal, the reading range will be shorter. So if your reading range is shorter, you need to tune your RFID reader antenna, or here we have the impedance matching circuit we need to tune to get the maximum range. So that was the technique how we transfer the data between reader and tag. So that was all about this. Thanks for watching.